All right, this is Mr. Gillum, and today we're going to talk about inequality applications. So you guessed it, we are going to do some word problems with inequalities. So we did a really nice job on the equations applications, which was word problems with equations. So I have a feeling you guys are going to do a nice job on these inequalities as well. And so here's some keywords here just to keep in mind. These are the big ones. They're just basic ones. We have our greater than or equal to sign. So if it says greater than or equal to, obviously it'll be a greater than or equal to sign that we're talking about when we're setting up our equation instead of an equal sign. This is the big one though, the at least. At least, that's an important one. Okay, the words at least. If you see at least, that means they need to be this number or greater than. So we use the greater than or equal to sign. When it's greater than, they pretty much come out and say it, it's greater than. This is another really important one, at most and at least. At least means that much or more. At most means that much or less than that. Okay, so that's a less than or equal to sign. So these are some keywords to keep in mind. It may be good for you to, while you're doing your worksheet, keep this out to remind yourself of the what the terminology means and what it's asking you to do. It can be a little confusing sometimes. So let's take a look at some examples. And it says your weekly base salary is $150. You earn $20 for each cell phone that you sell. Write and solve an inequality that represents the number of cell phones you must sell to make at least $630 a week. Okay, so this is a lot like our linear, or like our equations. This time we're doing inequalities. So it tells me that what we're shooting for is 630. And it says at least 630 is what we need to make. So we need to make 630 or more. So if that doesn't make sense as a greater than or equal to, we need to be bigger than or equal to 630 because we need to have at least 630. You can always go back here and take a look here. We're thinking about greater than or equal to 630. All right. The thing that's constant that never changes is your salary. Okay, it's not going to change, so that's not going to have a variable on it. You always get paid $150 every week, no matter how many cell phones you sell. The thing that does change is the number of cell phones you must sell. So that's where our variable is going to come in. But I do earn $20 for every cell phone I sell. Okay, so this is my inequality. All right, and so it just says your weekly, it says write and solve an inequality. So it does say write and solve, so let's go ahead and solve it as well. In this case, we're going to start by subtracting 150, and just keep in mind the goal is to get the n isolated or by himself, however you want to think about it. Greater than or equal to, what would that be? 480, and then divide by 20. So in this case, n will be greater than or equal to 24. Oh, no. Let's see here. 5, 10, not 24. Let's see here. 5, 5, 5, 5. So there's 20, 1, 2, 3, 4. Yeah, 24. I was right. Okay, so there we go. That represents the number of cell phones we have to make. We have to make sell at least 24 cell phones, or we could sell more than that, and those would all be bigger than 630. Notice how my inequality sign stayed the same because when I divided, I only divided by a regular number, not by a negative number. Okay, number 2, the Technology Club is trying to raise $1,000 raffling boards. They have already made $100. If they sell raffle tickets for $5 each, how much more to make at least $1,000? So once again, they're shooting for $1,000, right? It says that twice in the problem. It says it right here. That's what they're trying to do. It says it right here. And they need to make at least that. That's not the cap. They need to make this much or more than that much. Okay, it needs to be more than, so 1,000 is the least they can do. They need to make more than that. So this needs to be an open towards this side of the 1,000. All right, they have a constant. They already made $100. That's not going to change. They've always got that $100 in their pocket. We call that a constant, and we don't put a variable on our constant. It says, how many more must they sell? This is our unknown, how many they're going to sell. So I know they're going to make $5 for every one that they sell. So if I can figure out what n is, I know how many it'll take to equal 1,000, or I can say they can spend more or sell more than that and be more than 1,000. So let's go ahead and solve and see how many it says. 5n greater than or equal to 900, and I'm going to divide it by 5. And so here's another good practice of our long division skills. 1, 4, 0, 8, 40, 0, 0, 180. So in this case, n is greater than or equal to 180. So if they sell 180 tickets or more, then they will meet their $1,000 benchmark that they're trying to get. Okay? Take a look at number 3. It says an RV park receives $300 per month for each residential site that is occupied, as well as $2,000 per month for their overnight sites. Write and solve an inequality to find the number of residential sites that must be occupied to make at least $14,000 in revenue each month. So once again, I see this at least sign. So 14,000 is okay. Anything more than 14,000 is okay. So I'm going to start with this guy right here. Okay, at least 14,000. Whatever I make has to be bigger than or equal to 14,000. It looks like it says they receive $300 per month for each residential site that is occupied, as well as $2,000 per month for overnight sites. Right? Solve an inequality for the number of residential sites that must be occupied to make at least $14,000 in revenue. Okay, let's see here. This one's really tricky. This is my flat rate, my constant, 2,000. That's never going to change. Okay, they make $2,000 for their overnight sites. Okay, just for having the sites. They get another $300 per month from each one that's occupied. So that gave me the tip too that my unknown was how many must be occupied. I knew that my variable is going to have to go with the occupied sites, which I'm receiving $300 per month for. So I'm going to say $300 for every occupied site, N or X or whatever you want to use, plus the $2,000 I'm getting for every month just for having the overnight sites has to be more than 14,000 or equal to 14,000. So now I have my inequality set up. And I'm just going to solve it like we always do. Same steps as always. N is greater than or equal to, it's like it's going to be 40. See, would that make sense? Yes, it would. So they'd have at least 40 residential sites occupied in that month to make at least $14,000. Okay, at least 40, and we're occupied. At least 40 occupied. All right. Let's take a look at one more here. It says an animal shelter has fixed weekly expenses of $7.50. Okay, when it says fixed, that means it never changed. That's an important word. Okay, it says each animal in the shelter costs an additional $6 a week. That sounds to me like that's going to change, but for each animal. So I think I'm probably going to end up with a variable on the $6. So during the winter months, the weekly expenses are at most $900. So as expensive as it's going to get, 900 is the limit. Okay, right? Solve an inequality that represents the number of animals at the shelter for expenses to be at most $900 a week. So now we have a different thing. Before we had at least, now we have at most. So it's okay to be 900, but we got to keep everything that's going on below 900. Okay, so that's why we're using the less than sign this time. Okay, now the fixed cost that never changes is the $750. That's going to cost $750 no matter what. Each animal costs additional $6 a week. So if I'm looking for the number of animals, we're going to say $6 for every animal plus the $750 it's going to cost no matter what. It has to stay below $900 or equal to. So now I just have my inequality and I just go to work solving them. And we divide, and must be less than or equal to 25. All right, less than or equal to 25. And if you want the long division, I can show you that too. We're probably getting pretty good at this by now. 25. Okay, so they need to keep less than or equal to 25 animals. All right. We've got time for one more here. It says you borrow $200 from a friend to help pay for a new laptop computer. You pay your friend back $12 per week. Right? And solve an inequality to find when you owe your friend less than $60. So we want our answer to be less than 60 bucks. Okay? I mean, it just goes right out there and says it. It has to be less than 60. Now, we're starting with the 200 bucks that my friend gave me. Okay, that doesn't change. It's always going to be 200 bucks. That's how much I owe him. But this debt is going down this time, okay? You're paying them back. So the debt itself, the $200 is going down $12 per week. So now if I solve this inequality, it's going to say, okay, I have 200 bucks minus 12 for however many weeks go by. I need to know when it's going to be less than $60. Okay, so there's my inequality. So it's very similar to the equations that we solved. So I'm just going to go ahead and subtract 200, negative 12W is less than negative 140. Is that right? Yep, it looks right. I think I got all the numbers right. 200 in there, 12 bucks per week, less than 60. Okay. Divide by negative 12. Okay. So now here, this is important. See, we're dividing by a negative number. We didn't have to do this on the other ones. It was always positive. Now we're dividing by negative. I need to change the direction of my inequality to a greater than. And my negative divided by negative cancels out. Let's reduce this beast right here. 70, 35 thirds, greater than 35 thirds. But since we're talking about weeks, let's go ahead and find the nearest week. So 3 goes into 35 11 times, 11 and 2/3 weeks. And that would make sense for the problem. We wouldn't say 35 thirds weeks. So really, we're looking for anything bigger than 11 and 2/3 weeks. So we'll say at least 11 and 2/3 weeks. And the best answer might even be, if you were choosing on a multiple choice test, if it has to be at least 11 and 2/3, you'd probably just say, if you were rounding the whole weeks, you'd say at least 12 weeks. We can be specific for this one though, that's fine. And that's it for today, applications of inequalities.